is Nick Legler, and I work as a fisheries biologist with the Wisconsin DNR stationed in Sturgeon Bay, Wisconsin. And today I would just like to present some basic updates on behalf of the Lake Michigan Salmonid Working Group. And I'd like to acknowledge and thank the many agencies and individuals from all around Lake Michigan who contribute to this effort every year. Many of these efforts are conducted by official members of the Lake Michigan Salmonid Working Group, which are listed here on the slide. And then certainly there's many other individuals from agencies around the lake, particularly with the creel programs and the Great Lakes Mass Marking Program, which also help out. So the primary role of the Lake Michigan Salmonid Working Group is to annually update the Lake Michigan predator-prey ratio analysis. And we are currently in the process of finalizing some of the modeling results that are used for the predator-prey ratio analysis, and we anticipate having those results completed very soon here. But for the purpose of today's talk, I will simply share what I do have updated right now through 2019. The overall structure of my talk today will be pretty simple. I'm just going to run you through several of the data sets here highlighted in blue, including the data inputs for the Chinook catch-at-age model, and then several of the auxiliary indicators, which again will all be updated with data through 2019. So the predator-prey ratio analysis uses statistical catch-at-age models, including a catch-at-age model for Chinook salmon, which is used to estimate total lake-wide abundance of Chinook salmon, which is then ultimately converted to a total lake-wide biomass of Chinook salmon, which is used in the predator-prey ratio to evaluate balance between Chinook salmon and alewife. This slide here just highlights the many different data sets that feed into the catch-at-age model for Chinook salmon. And the four that I'm going to highlight today are numbers of Chinook salmon stocked, numbers wild, angler hours, and angler harvest. Again, this will all be data through 2019. So first, taking a look at numbers of Chinook salmon fingerlings stocked into Lake Michigan. This slide is updated from 1967 to 2019. You can see here, just to point out a few things, Chinook salmon stocking peaked at about 7.8 million in 1989, and since, stocking has generally come down. There's been several stocking adjustments or reductions implemented. The four recent ones here highlighted in green. These stocking reductions have been implemented in an effort to try to balance predator and prey in the lake. And you can see most recently here, 2019, about 1.55 million Chinook salmon fingerlings were stocked. So in addition to stocked Chinook salmon in Lake Michigan, we also know through various marking and tagging studies that there is a fair number of wild Chinook salmon in Lake Michigan, which are contributing to the fishery as well. Most recent estimates of wild production for Chinook salmon were derived from the Great Lakes Mass Marking Program. And this slide just shows the numbers stocked in blue, and then the estimated numbers of wild Chinook salmon fingerlings in white. So for the past 10 years, percent wild at age 1 has averaged right around 54%, including a high in 2013 of 64%, low in 2014 of 38%, and then for 2018, so this was our, or for the 2018 year class, estimated at age 1 for last summer in 2019, it was 46% wild, which was a little bit below the recent average, but kind of right in the ballpark of 50%, which is what we typically see. So next I'll take a look at angler hours. So this slide shows targeted angler effort for salmon and trout, and this is effort for all of Lake Michigan for boat only, including both charter and non-charter anglers. So this effort peaked at almost 9 million hours in 1986 and generally has been decreasing since for the past 34 years. For the past 11 years, we've averaged right around 2.26 million angler hours. And for 2019, we had 1.98 million angler hours, which is actually the lowest effort recorded on this entire time series. And just to give you a snapshot of angler effort by state for just 2019, I have it broken down here. You can see Michigan is the biggest effort, followed closely by Wisconsin, and then Illinois and Indiana. So next I'll take a look at angler harvest for Chinook salmon, which is plotted here. This is for all types of fishing except for stream. And generally, we've seen some increases and decreases in harvest. From 1986 to 1993, harvest generally decreased. During the same time period, stocking was actually very high and increasing, but harvest was relatively low. This was during the era of bacterial kidney disease. Subsequently, we saw increases in harvest despite the fact that stocking was actually being reduced. There was improvements in the fishery post BKD, and we increased to actually the second highest harvest in 2005 at over 800,000 Chinook salmon harvested. And then since, with the exception of 2012, which was a very high harvest year, harvest in Lake Michigan of Chinook salmon has generally been decreasing. In 2019, just over 148,000 Chinook salmon were harvested. So there's a lot of factors that impact harvest in a big lake like Lake Michigan. I mentioned earlier, effort has generally been decreasing, so certainly that's coming into play here. And then certainly the stocking adjustments that have been implemented recently to balance predator and prey have reduced the numbers of Chinook salmon in the lake, which is likely coming into play here as well. But kind of a positive aspect of that is we've seen in recent years relatively big Chinook salmon in Lake Michigan because of largely because of those stocking adjustments. And then again, this is just a snapshot for 2019 showing the total numbers of Chinook salmon harvested by state. So again, we're currently in the process of finalizing the predator-prey ratio analysis and the model results with data through 2019, and those should be available very soon here. But just as a quick review, these are last year's results of the predator-prey ratio updated with data just through 2018. So on the top figure here, we have total lake-wide biomass of Chinook salmon, which has generally decreased since 2012. In the middle, we have total lake-wide biomass of alewife. This is estimated using trawl data, using hydroacoustic data, and also using estimates of consumption and fish size by all of the different salmonids. And based on these model results, alewife biomass has generally been, again, decreasing, and the last 5 years have been the 5 lowest years of alewife biomass recorded here. And then if we divide the top figure, Chinook biomass, by the middle figure, alewife biomass, we can look at this in terms of a predator-prey ratio, or a ratio of Chinook salmon to alewife. And the predator-prey ratio was generally high in 2012, and following stocking reductions to balance the predator-prey, we did see an improvement in the predator-prey ratio. Again, this is just a review of last year's results, and very soon here, we will be able to update this with the 2019 results. So in addition to the predator-prey ratio, we also look at several what we call auxiliary indicators, which are just simple data sets plotted through time that allows fisheries managers to look at some different trends and to provide some additional information that can be used to help guide fisheries management decisions, and also to kind of ground truth what we're seeing in the predator-prey ratio. So I have 4 of these today that are all updated with data through 2019, which I will take some time here to summarize. And first, I will look at the average weight of an age 3 female Chinook salmon. These average weights are calculated from fish all around Lake Michigan, including spawning weirs in Michigan, spawning weirs in the state of Wisconsin, and then the state of Illinois does not have spawning weirs, but they do harbor electrofishing surveys in the fall, and we get information from those surveys to feed into this average weight. So this slide just summarizes the numbers of fish that we're looking at for these average weight calculations. So for 2019, we had over 1,000 Chinook salmon that were included in this analysis, including 3 spawning weirs in Michigan, the Illinois harbor surveys, and then 3 spawning weirs in Wisconsin. And this figure just shows the sample sizes broken out by state. You can generally see here bigger sample sizes in the state of Wisconsin, and that's simply because we collect a lot of coated wire tags at our weirs, and we have a lot of known age fish. You know, for example, the Root River and Besadney, we actually currently have a net pen study ongoing at those rivers where fish were differentially marked with coated wire tags. So for that study, you know, we've been collecting a lot of fish, and we have a lot of coated wire tagged known aged fish. So this is just a snapshot of those average weights for 2019 per location. Generally, we saw bigger fish in Wisconsin, smaller fish in Michigan, and then kind of a mid-range fish in Illinois. And this just shows the perspective of the average weight of an age 3 female Chinook salmon through time for each of the individual locations plotted separately here as a different color. So if we focus in just on the move from 2018 to 2019, several locations did decrease in weight, including Strawberry Creek, Besadney, Boardman, Little Manistee, and Medusa Creek. We saw decreases in average weight at all those facilities, but there were a couple locations, the Root River and in Illinois, that we actually saw increases. And if we look at all of this data using a weighted average, this is the overall average weight of an age 3 female Chinook salmon across the lake. So in 2019, the average weight was 21.1 pounds, so relatively big fish. So it's important to acknowledge that during many of the past years, so 13 of the past 18 years, we've actually seen below average fish in Lake Michigan, including many years with highly variable weights. But kind of a positive thing is that for the past 4 years now, we've seen consistently big Chinook salmon in Lake Michigan. Again, alewife biomass remains historically low, but with some of the stocking reductions that were recently implemented, we've been able to see an improvement in the predator-prey ratio. And one very positive aspect of that is we've seen big fish, big Chinook salmon in Lake Michigan. So another weight indicator that we look at is the standard weight of a 35-inch Chinook salmon. This is calculated from angler caught fish sampled during the summer. And for any anglers that might be watching this presentation in the future here, this is just a very simplified example of how we calculate a standard weight of a 35-inch Chinook salmon. So on this figure, each of these white dots represents an individual fish with its weight on the y-axis and its length on the x-axis. And then we run a regression analysis line through this data set. And then where those lines cross, you can get the standard weight of a 35-inch Chinook salmon, which in this particular case is 17.7 pounds. So again, for 2019, these are our sample sizes. This data set includes creel sampled fish as well as fish from the mass marking program collected in each of the individual states. And just for some perspective, this is our overall sample size through time. You see a big spike in sample size there in 2012, and that was thanks largely to the Great Lakes Mass Marking Program. And then again, a snapshot for 2019. This is the individual length weight scatter plots for each of the states and each of the sample types, creel and mass marking. The scales are identical on all of these figures, and you can generally see similar patterns throughout the lake. And this is the overall standard weight of a 35-inch Chinook, again for 2019, across the lake for the different sampling types. And this is the same data, but showing you the historical perspective. Again, looking just from 2018 to 2019, Michigan saw a decrease in the standard weight. Wisconsin actually saw an increase, and then Illinois saw an increase as well. And if we look at this data collectively using an average, a weighted average, the overall standard weight of a 35-inch Chinook salmon for 2019 was 17.6 pounds. So similar to the weight at age 3 that I showed previously, It's important to acknowledge 10 of the past 16 years we've been below average. However, during recent years, for the past 4 years now, we've seen consistently big Chinook salmon in Lake Michigan. So next I'll look at targeted harvest of Chinook salmon by charter boats. Generally, we have seen a decrease in harvest of Chinook salmon by charter boats since the mid-2000s. For the last 7 years, we've been below average. And overall for 2019, this total lake-wide harvest by charter boats was about 42,000 Chinook salmon. And then this bottom figure shows you that same harvest data, but broken out by each of the individual states. And next I'll take a look at effort. So how many hours are charter boats putting in to this fishery? And this figure here shows effort from 1999 to 2019. And generally, this effort has fluctuated up and down right around that long-term average of about 643,000 hours. During the late 2000s, from 2013 to 2015, we had a stretch where we were above average. During very recent years, we've pretty much been right at that historical average. For 2019, this total effort was about 630,000 hours, which stepped just below that long-term average. And this just shows you the breakdown in effort by individual states. So overall, if we divide harvest by hours fished, we can look at this in terms of a catch per unit effort. And generally, with decreasing harvest and somewhat constant effort, we've seen a reduction in the catch per unit effort of Chinook salmon by charter fishermen. This peaked at about 0.3 Chinook salmon per hour. For 2019, it was about 0.067 Chinook salmon per angler hour for charter boats. And I'd just like to clarify that this is numbers of Chinook salmon caught per angler hour. Certainly, if you were to look at this as the number of Chinook salmon caught per charter fishing boat per hour, this number would be much higher, simply because there's usually many anglers and many lines being fished on a charter fishing boat. And then this just shows you harvest per hour by charter boats broken down by each of the individual states. Generally, we saw similar patterns here across the lake, but one point that I wanted to emphasize here is that you see a pretty big increase in catch harvest per hour by Indiana charter boats last year. And just to look at that a little bit closer, this figure here zooms in just on targeted harvest of Chinook salmon by Indiana charter boats. And you can see that there was a low of only 29 Chinook salmon caught in 2017, up to over 1,000 Chinook salmon caught in 2019. If we look at that in terms of effort, there was a low of about almost 4,000 hours fished in 2017, and that spiked all the way up to over 13,000 hours fished in 2019. So Indiana actually had a pretty good year last year for 2019 for Chinook salmon being harvested by charter boats, and this was particularly early on in the season when they were catching a lot of fish. And then I'll just briefly mention too that the Indiana charter boats do catch more fish than what's reported here, but a lot of them are actually fishing across the border in Michigan waters. So the numbers reported here are simply Indiana charter boats fishing in Indiana waters of Lake Michigan. And then I'll notice too, the top title of this figure says just through 2018. That's an error. This should actually be, the data here is through 2019. So next I'll take a look at lake-wide sport harvested weight. So, what's being caught in terms of other species out in the lake, not just Chinook salmon. So this slide shows the lake-wide sport harvested weight expressed as a percent composition by species. And you can see throughout this entire time series, Chinook salmon by weight has been a dominant component of the fishery. It peaked at 85% of the weight in 2006. Since it has come down, in 2019 it was 47%, but still a major component of the fishery by weight. And another way to look at this same data, instead of looking at it as a percent composition by weight, we can simply look at the harvested weight. So this has the individual harvested weight per species. I'll note the scales on these figures are all different, but I wanted to show this just to highlight some of the basic patterns. So during recent years, we've seen generally a reduction in Chinook salmon and brown trout harvest by weight. Rainbow trout and coho salmon have fluctuated quite a bit from year to year, but held somewhat constant. And then we've seen a pretty big increase in lake trout harvest in terms of harvested weight during recent years. So just a very quick and basic summary, Chinook salmon harvest and angler effort have generally decreased during recent years. Alewife biomass remains historically low, with record lows the past 5 years. Again, this is based on the catch at age modeling, which includes the trawl surveys, the hydroacoustic surveys, as well as consumption and fish sizes or growth. And then the predator-prey ratio, or the ratio of Chinook salmon to alewife, has generally improved during recent years compared to some of the higher ratios that we've seen in 2012, for example. And kind of a positive side of that is we've seen relatively big Chinook salmon in Lake Michigan now for the past 4 years. So again, the purpose of my talk today was just to give you a basic snapshot of some of the data updated through 2019 that's used with the predator-prey ratio analysis. We should have the final results of the predator-prey ratio available here very soon within the coming days or weeks. And I look forward to sharing that with everybody once it is finalized. So with that, I know this talk is being recorded and will be posted online. If there's anybody out there viewing the talk that has any questions, feel free to reach out to me. And I've got my email address listed here. Thank you.